In this video, we're going to use a join statement to join together two tables from a SQLite database, and we're going to show the results in a search and details fragment that we created in a previous video. Now, why a join statement? The reason is we're looking at specimens of plants that we have added on our phone. Now, a plant is a scientific definition of a plant. It has things like a common name, genus, species, category, origin. Where is it native? Is it recommended? Is it drought tolerant, sun tolerant, so on and so forth. Where a specimen is kind of like a single plant that we would see, we can touch, we can take a picture of. You see, each of these bullet points that we see here is a specimen. Now, the trick is, specimens, we're going to get the plant data from our online data source. The specimens we're going to create and save on our phone. Now, what does a specimen have, though? A specimen is really just a latitude, a longitude, and maybe a location, maybe a description, not much more than that. When we think of searching, we're typically thinking of searching by the plant name, and that's part of the scientific definition of the plant. So we have to do a join statement because we want to search the plants table and then find specimens that are related. We've already created our user interface and we've already populated it with some stub or prototype data. So now we simply need to make the actual implementation. We're going to do that in this class called Offline Specimen DTO, which implements iSpecimen DTO, and iSpecimen DTO is the same interface that our stub or our prototype implements. So I go to the search statement and the search method, and the first thing we need to figure out is what is our SQL statement going to look like. So I'm going to say string SQL equals, and then we're going to say select star from. Now remember, we used constants, and that's going to pay off right now. Plants is our plants table name. Okay. Actually, I'm sorry, specimens. That's our specimens table name. Now, here's the important part. We need to give this an alias, and we're going to call it S, because we're going to have both a plants table and a specimens table. I'm going to say plus, now join, which means we're joining two tables together based on a shared key. Join plants, that's our constant that we declared earlier for plants. And again, we're going to give that an alias. We'll just call it P. Join plants P, and then we'll say on S dot, okay, and then what was the name of the column that we're using from the specimens table to join to the plants table? In other words, what's the foreign key? It's plant. In this case, we're going to use plant cache ID on S dot plant cache ID equals, and then we'll say, I actually say equals P dot, okay, and then we'll say cache ID. And again, all of these constants I'm using I've defined in an earlier video. Okay, and then we'll say where, but hang on, before I get too far into the where statement, notice that we're using this S alias here, and then we're using a period to separate the S alias from the field, the plant cache ID, which is the foreign key on the specimens table to the plants table. On the plants table, we're using the cache ID, which is the locally created auto-generated primary key. Okay, now we can add a where clause. We can say where P dot, and then we'll say genus, okay, like, and then single quote %, and then plus search term, plus double quote, % single quote, or, and then double quote, and then plus. Now, what in the world did I just type there? I'm saying where the column called genus contains the search term anywhere. So that's a wildcard. That means this search term is a part of any value in the column genus. But I want to search genus, species, cultivar, and common. So I'm going to want to repeat this for each of those. Or, and then we're going to say P dot plus species. Now luckily I can at least copy the rest of this. like search term or, and then we'll kind of do a little bit of duplication here, except I'll replace species with cultivar. And one more time. This time I replace species with common. Now the last one, I don't need to append that or qualifier. I think we're good there. I just need to terminate this with a semicolon. Okay. And now what we're going to do, let's see, we know that's assembling the SQL statement. So now what we're going to do is we're going to execute the SQL statement. Okay, we're going to say get readable database, which means we just want to read records. We don't need to lock any rows. Get readable database.raw query, and we're going to say SQL and then null. We've handled the parameters by ourselves, so we don't need to specify any parameters. Control-Alt-V will take the result of calling raw query and save it to a local variable, and that's a cursor. Okay. Now, anytime we get a cursor, we immediately want to think about closing that cursor when we're all done. If not, we could run into some memory issues. So before I do anything else, cursor.close. Okay. Next, what I want to do is iterate over the results. And I also want to declare a collection that will hold the results. So we're going to say array list, and we have to be careful here. Let's look at our return type. We are returning a plant DTO. So array list plant DTO, all plants equals new array list plant DTO. When we look at that, we realize we might need to change our query just a little bit. We go ahead and import array list, and before I forget, let me return this array list. What we're going to want to do is, see, we're just saying select star. We need to return some information from the plants table and also some information from the specimens table. So instead of select star, let's break this up and let's say select P. This can be a little bit tricky. P in quotes dot and then genus comma. I'm going to copy that and reuse that a few times. And actually the comma shouldn't be there. So we'll do like this. Just a moment. Okay. Select p.genus, comma, and then we'll say p.species. Okay. And then we'll say p.cultivar. Let's just say, yeah, cultivar, fine. Okay. p.common. Okay, move the from down to a new line. We're going to need plenty of space on this one because we still need to also select our S's. So we're going to say S dot, and we're going to say latitude. Oops, did the comma trick again. Plus double quote comma. Plus, okay. And then copy and paste S dot longitude. Okay. S dot location. And finally S dot description. And then after that we can take off, okay, and just go straight to the from. Okay, doesn't like something I've done here. What did I do wrong? So S dot, what do we have? Oh, I'm missing a plus here, aren't I? Okay, so we had the plus. Okay, now a lot of syntax going on here. Let's check very closely, make sure I've done it right. The P means I'm selecting it from the plants table. So p.genus, p.species, p.cultivar, p.common, all followed with a comma and a space. S is from the specimens table, so latitude, longitude, location, and description. All looks good, no comma after the description, that looks fine. Okay, now we're going to go ahead and iterate over the plants, iterate over the results. And we're going to need to create both a plant DTO and a specimen DTO object as we do this. So we say cursor dot move to first. And first of all, we'll wrap that in an if test. If cursor dot get count greater than 0. Okay, we only want to do this if we got results. Then cursor move to first to let me wrap that all in a curly. Okay, then we'll say while, and I've done this in previous videos. You can certainly look to those to see a deeper explanation of what I'm doing here. While cursor is not after last. Okay, open curly, close curly. If you're going to do an iteration like this, if not cursor is after last, before you do anything else, within the while loop, say cursor dot move to next. Do that at the very bottom. Do that right now, because if you don't, you'll forget and you'll end up with a nasty infinite loop. And save. Okay, now finally, cursor dot get. Let's see, what's our first item? Our first item is genus dot get string. And you know what I should do is I should include that cache ID. But since we're just displaying them now, it's not going to make a big difference. We're mainly just worried about display. So cursor.getString, and let's do column count 0, column index 0, and that's going to be our genus. So Control-Alt-V, and we're going to call this genus. Okay. Cursor.getString 1, and that will be our species. So Control-Alt-V, again, species. Okay. Cursor dot get, let's see, cultivar is next, get string, and we'll say 2, and that will be our cultivar. Control-Alt-V again, cultivar. Okay. Cursor dot get string 3, Control-Alt-V, and that's our common name. So that's the plant data. So I'll simply say here plant data. Okay, and now we need to get the specimen data. Okay, so okay, we'll say, let's see, latitude, longitude, location, description, those are all strings as well. Cursor dot get string. Let's see, and we left off with 3, we'll go to 4. There are several other ways we could do this. We could do cursor dot get string, and then in that cursor dot get column index, or we could use like a variable here and say I++, something like that. As a matter of fact, that's probably even better. Int I equals 0, I, whoops, and then we'll add one to let's keep it as it is. That's going to get confusing because we'd have to do actually ++I, but that's okay. Cursor get string 4, Control-Alt-V, and this one is latitude. Okay. Cursor dot get string 5. Okay. Control-Alt-V, and this one is longitude. Okay. Cursor dot get string 6, and this one is location. Cursor dot get string, and I think we're up to 7. And finally, that one is description. Control-Alt-V, description. You see, we're a bit brittle here because we're going with the ordinal number of these columns up here, and that's why I say it's a little bit better to say cursor dot get column index, but for our purposes this will work. Okay, now what I'm going to do is I'm going to say plant p equals new plant. Okay, and actually I can do this up above. Let me do this up here. And let's call it plant equals new plant. And is it plant or plant DTO? Looks like it's plant DTO. Okay, yep, there we go. Now we'll say plant dot set genus, oops, plant dot set species, plant dot set common, a little out of order, that's okay, common, plant dot set cultivar. Okay, so taking the data we received from the results and putting them into our plant DTO. Same thing with the specimen. Specimen DTO, specimen equals new specimen DTO. Let me fix my capitalization. Okay. Specimen dot set latitude, latitude. Specimen dot set longitude, longitude. Specimen dot set location, location. Specimen set description, description. Okay, now finally, if we go to our plant, we can set specimens, but we need to put those in a list as well. Okay, just a moment. Array, or let's just say list, list, specimen DTO, all specimens equals new list specimen DTO. Now we're telling a little bit of a lie here because we're only giving one specimen per plant, where the plants can actually have multiple specimens. Let me change that to array list. There are more efficient ways we can do this where all specimens for one plant will go to only one plant object. But for our purposes right now, we'll just keep it as it is. Okay, finally, plant.set specimens. Whoops. All specimens. Okay. And then we'll say, what was our collection? All plants. All plants dot add specimens. I'm sorry, all plants dot add plant. And then we finally return all plants. Okay, and I save. So we're selecting from the plants table with a fairly long query, but nonetheless selecting from the plants table. And then we're iterating over that. We're creating a plant DTO, creating a specimen. Okay. Add the specimen to the collection. Okay. Add the specimen to the plant. Okay. Add the plant to the collection of plants. Okay. And save. Okay, now I'm going to go back to the GPS screen, just a moment. GPS a plant. And actually, no, we're not. We're going to go to the specimen show fragment, aren't we? Yeah, the specimen show fragment. I'm going to change the search from redbud. I'm just going to make it really loose and make it just the letter E. That will return, we only have 2 specimens in there anyway, but that will return a large number of specimens. Now here's the important part, and here's where using interfaces is really nice. Do you see the stub that we've been using so far? All we need to do to change to our live implementation is change this constructor to say offline specimen DAO, and then it's going to require a context, so we'll pass in get activity, which gets the activity that owns this fragment. And then we save. And now let's run and see what results we get. The emulator has come up. I click on Show Saved, and I'm expecting to see 2 plants that I have GPSed and saved before. Sure enough, Begonia Whopper Red with bronze leaf and Cercis canadensis Eastern Redbud. We could probably change this to show some of the details of the specimen as well, things like the latitude and longitude. We simply need to override the toString method. Another thing we could do is we could make this clickable, so we click and we possibly see some details. Let's play around a little bit more. Let's say, well, what's another plant that has the letter E in its name? I guess we could say maple. So I type in maple. And with any luck, we'll get some autocomplete here. I'll just pick one. Trident maple, that's fine. Location, we'll say St. Bernard, Ohio. Description, beautiful specimen, something like that. And then save. Okay, I have some breakpoints I've forgotten about, so let me disable those and choose F9, which just says OK, continue. One more breakpoint, we'll disable that, F9, continue. We should probably have some visual indicator when it's saved. On the liveplantplaces.com, when you hit save, the background color changes to green, And then once you click in the plant name, everything blanks out and it changes back to black to kind of give a little bit of a visual indication. In any case, let's hit Show Saved again, and let's see what our results look like now. Sure enough, take a look. There's our Trident Maple. You can say we saved it on the previous screen, went to the results screen, and immediately there it is. Now we don't have this search term wired up yet. That's going to require a little bit of activity and fragment interaction. We'll take a look at that in our next video. Meanwhile, thanks for watching this video on creating a join in SQLite.